Welcome, everyone. My name is Amar Dhamdere, and I'm a Principal Product Manager for Azure ARM VMs at Microsoft. Today, we'll explore Azure's Cobalt 100 VMs and their role in modern cloud workloads. You'll learn what sets them apart and how they combine performance with cost efficiency. We'll share a demo and practical steps to help you get started. In this session, I'll be joined by Pooja Thakur from the Azure Boost team. Together, we'll break down Cobalt 100's capabilities, show you how they fit into your cloud strategy, and walk through deployment best practices. We are making this video to show you how to unlock the full potential of Azure Cobalt 100 VMs, bringing breakthrough performance, efficiency, and flexibility to your cloud-native workloads. Our goal is to help you understand their advantages and give you the confidence to adopt ARM-powered infrastructure for your applications. Think about handling more users without scaling out or cutting your cloud bill without sacrificing speed. That's the promise of Azure's ARM-powered VMs with Cobalt 100. But first, let's zoom out and look at the broader Azure VM portfolio. Azure has recently launched new VM series across nearly every category, bringing major improvements in performance and price performance. These VMs are designed to support a wide range of workloads, from enterprise apps and cloud-native services to HPC and AI. With enhanced security and reliability, Azure's portfolio gives you the flexibility to choose the right VM for your needs and optimize both cost and performance. Since last fall, Azure has launched new general-purpose and memory-optimized VMs powered by three leading CPUs: the Azure Cobalt 100, AMD's 4th generation EPYC, and Intel's 5th generation Xeon processor. These V6 VMs deliver major improvements in compute, memory, storage, and networking, plus at least 10% better price performance compared to previous versions. Looking ahead, we are continuing to expand the portfolio with new V7 VMs. AMD-based V7 VMs and Intel-based V7 VMs are the next wave of innovation. These additions will bring even more performance and flexibility for your workloads. Azure Cobalt is Microsoft's first custom silicon ARM processor for the cloud. It is engineered for exceptional performance and efficiency, leveraging ARM's latest technology and advanced 5-nanometer process. With support for up to 96 vCPUs per VM and 12 channels of high-speed DDR memory, Cobalt 100 delivers outstanding scalability and memory bandwidth for demanding cloud workloads. It's designed to optimize performance per watt with dynamic power regulation that lets us balance speed and efficiency for any workload. ARM started in mobile and IoT, but now powers everything from client devices to supercomputers, and with Cobalt 100, Azure brings that innovation to the cloud. Cobalt 100 is Azure's own ARM processor, purpose-built for cloud-native performance and cost savings. The Cobalt 100 VMs outperform previous generation ARM VMs and delivers better price performance than comparable x86 VMs. Compared to the previous ARM v5 VMs, you'll see up to 2x higher throughput for web and .NET workloads, and up to 1.5x better performance for Java applications. You also get faster memory bandwidth, higher I/O throughput, and more network capacity, thanks to Azure's platform optimizations. The bottom line, Cobalt VMs can help you serve more users for your applications, reduce latency, and lower your cloud costs, all with minimal changes to your application code. Azure's Cobalt V6 VMs come in 3 series, each designed for different workload categories. The DPLS V6 series offers 2 GB of RAM per vCPU, scaling up to 96 vCPUs and 192 GB RAM, ideal for memory-efficient workloads like media encoding, small databases, and microservices. The DPSV6 series provides 4 GB of RAM per vCPU, up to 96 vCPUs, and 384 GB of RAM, perfect for web servers and small to medium databases. For memory-intensive workloads, the EPSV6 series delivers 8 GB of RAM per vCPU, up to 96 vCPUs, and 672 gigabytes RAM, great for large databases, big caches, and analytics. All Cobalt v6 VMs support up to 5.3 terabytes of local SSD storage, 40 gigabits per second remote storage throughput, and up to 60 gigabits per second network bandwidth. You can choose between local SSD or a range of remote storage options, giving you the flexibility to optimize for performance and cost. As you can see, several Azure customers have deployed these VMs and are experiencing of up to 40% performance improvement compared to our previous ARM-based VMs. We expect to see more customers using Cobalt 100 VMs in the coming months, and we look forward to learning more about the benefits these VMs are bringing to a growing range of workloads. You can find more customer use cases in our GA blog. This slide highlights some of the most popular open source and developer framework technologies that are used to build cloud-native applications. .NET, Java, Python, Node.js, and C++ have all ARM-optimized versions, so developers can run their applications natively and efficiently. Popular databases like MongoDB, MySQL, PostgreSQL are also supported, making it easy to build end-to-end solutions on ARM. With libraries and tools now optimized for ARM, you can fully tap into the performance of Cobalt 100 VMs. The ARM ecosystem is ready for your most demanding workloads. It's 2025. ARM isn't experimental in the cloud anymore. It's a first-class platform. You can bring your cloud-native app to a Cobalt VM with confidence because most workloads built on modern runtimes run on ARM with minimal modification, thanks to broad ecosystem support. To illustrate how you can deploy and run actual workloads using Cobalt 100 services, we'll use a sample e-commerce application, a basic storefront with services for product info, order processing, and messaging. I won't cover the full tutorial here, but if you're interested in building a storefront app for Azure, you'll find an excellent step-by-step guide at the link provided at the top of the slide. You can also scan the QR code to access it directly. Today, we are going to focus on performance. You'll see those results in the upcoming demo. By the way, I want to thank folks from ARM Holdings who helped us build this training. And also, please take a look at the webinar that we at Microsoft did jointly with ARM Holdings. This slide spotlights the core tools and runtimes for AKS. We use Azure CLI to create clusters, kubectl to manage workloads, and Containerd to run containers. YAML manifests for defining deployments. AKS supports multiple languages, .NET, Java, Node.js, Python, as well as C++, and Microsoft OpenJDK for high-performance workloads. Popular databases like MongoDB, MySQL, and PostgreSQL are supported as well, giving you flexibility for data storage and scaling. Together, these components make AKS a flexible, cloud-native platform. Next, we will see a demo of the performance of some of these components compared to the previous generation ARM v5 VMs. And after the demo, we'll have Pooja Thakur from the Azure Boost team give you an overview of Azure Boost, which powers the Azure Cobalt 100 VMs.
In the next few minutes, I'll walk you through a performance demonstration of the Azure v6 VM powered by Microsoft's Cobalt 100 ARM-based CPU. We'll compare it directly with our previous generation ARM v5 VMs to see how far we've come. On this screen, we have two virtual machines. On the left, a D16PS v5 instance. On the right, the new D16PS v6 powered by Cobalt 100. Let's start by verifying the hardware configuration of both VMs. As expected, both machines report 16 vCPUs. You'll also notice the CPU models differ. The v5 VM uses the ARM Neoverse N1. The v6 VM features the newer ARM Neoverse N2. Next, let's confirm both VMs are running the same operating system. Perfect. Both are running Ubuntu 24.04, just as we planned. I've already installed the e-commerce application. Let's make sure all the containers are up and running. Everything looks great. All containers are active and healthy. Now let's verify the web interfaces are accessible. First, we'll retrieve the public IP addresses. Then, we'll open the interfaces in our browser. Both interfaces are live and displaying the expected results. Now for the fun part. Let's run a local stress test to measure how many transactions per second each VM can handle. First, we'll install the benchmarking utility. Then, we'll start the test. Let's give it a minute. And here are the results. The V5 VM achieved 41,000 requests per second. The V6 VM reached 61,000 requests per second, a performance boost of almost 50%. Latency is also significantly lower on the V6, making it a clear winner in responsiveness. These VMs are not only powerful, but also incredibly easy to use. Have fun exploring what they can do.
Hi, my name is Pooja Thakur and I am a Senior PM for Azure Boost at Microsoft. You might wonder, beyond the CPU, how else does Azure squeeze out performance? That's where Azure Boost comes in. A suite of technologies that move key virtualization tasks from the main CPU to specialized hardware. This is one of the reasons our ARM-based Cobalt 100 VMs perform so well. In a traditional VM, the CPU handles everything. Your app, plus background hypervisor work like networking and disk I/O. Azure Boost offloads these to custom hardware, like SmartNICs and programmable offload cards. Our storage controller offloads disk encryption and I/O processing. The result? The Cobalt 100 CPU cores spend more time on your workloads and less on background tasks. With Boost, a Cobalt VM can achieve extremely high network and disk throughput without bogging down the VM's cores. In fact, we mentioned up to 60 Gbps networking on Cobalt that's enabled by the combination of Azure Boost networking and the ARM CPU's efficiency. Offloading also means performance is more consistent. Even under heavy network load, your CPU cycles remain available for the app. This leads to more stable latency and throughput. Azure built a custom security chip that works with Boost to maintain strong isolation between tenants. So you get the performance benefits without compromise on Azure's core security model. In short, Azure's infrastructure is optimized to complement Cobalt 100. It's not just a new CPU on an old platform. It's a full-stack optimization that combines years of innovation from accelerated networking and FPGA offloads into a seamless experience. The takeaway is, Azure has done the heavy lifting under the hood. For you, this is largely transparent. You will simply notice that network and data-intensive workloads run faster. By selecting a Cobalt 100 VM, you automatically benefit from all these new platform capabilities. There's no special switch. It's built into the product. So you can trust that Azure is delivering the best possible performance on this new hardware. Thank you. And back to you, Amar.
Thank you, Pooja. ARM in the cloud is here, and Azure Cobalt 100 makes it easier than ever to take advantage of it. Explore what's possible with cloud-native computing and start building today. The Cobalt 100 VMs are in 31 regions and support a wide variety of operating systems. Scan the QR code or go to the link mentioned to get started if you haven't already. Thanks for watching.